Today we're going to learn more about the graphs of trig functions and variations on those graphs. You already learned that a periodic function was a function that kept repeating itself at regular intervals, and sine and cosine are the most common of periodic functions. Probably the most important thing in this whole chapter is to know the basic shapes of sine and cosine graphs. Sine, you start in the middle, you go up to the top, down to the bottom, and back to the middle. Cosine starts and ends at the top. Cosine, if you turn your head a little bit sideways, it looks kind of like a C, and sine, if you turn your head sideways, it looks kind of like an S, backwards S, but you should be able to tell the difference between sine and cosine. The basic sine and cosine graphs always are somewhere between -1 and +1. The highest they ever go is 1, the lowest they ever go is -1. In class, we discussed how you can use a graphing calculator to graph trig functions. You don't have to use a graphing calculator, and in fact, a lot of times it's easier not to use the graphing calculator, but we are going to show you exactly how it works and how you can graph with a graphing calculator. The first thing we want to do is set the window on the calculator to something that makes sense for graphing trig functions. The default window on most graphing calculators goes from -10 to 10 in both directions, and what we need to do is make it fit a trig graph better. So to do that, you need to press the key in the top row that says Window. Here's a typical window you might use to make trig graphs. You notice I have this going from 0 to 360, counting by 90s. And on the Y, I have it going from -5 to 5, counting by 1s. Basically, we're stretching out the Y-axis and squeezing together the X-axis to make a whole graph fit nicely onto the screen that our calculator shows. If you set this, your graph will look pretty decent when you do graph trig functions. After you set the window, you can quit to get back to a blank screen. The way you do that is you hit second and then the key right next to second. If you look above mode, it says quit. Then, when you want to graph an actual function, you press the y equals key, which is in the top left-hand corner of your calculator. And on the first line where it says y1, you enter a function you want to graph. For instance, if you wanted to graph sine x, you hit the sine key, and then to put x on the screen, you'll find a key about 3 rows down that says x t theta n. Sometimes it might say x variable instead, and that's how you put the x on the screen. You can see I have this set to graph y equals sine x. Then if you hit the key that says graph up at the top right, you'll end up getting a graph of that function. And you should notice that same basic sine shape that I said we always have for sine graphs. You'll notice it goes as high as y equals 1, as low as y equals -1, and we had our window set to go from 0 to 360, so every 90 degrees it's switching positions between the middle, top, and bottom. You could do the exact same thing to graph cosine, just change sine x to cosine x, and you get that sort of U shape that we said cosine always had. Again, you don't need to use a graphing calculator, but if you happen to have one, you might as well know how it works, and that's how you go about graphing on a graphing calculator. What we're going to talk about today is how changing different parts of the equation and putting numbers in changes what the graph will look like. I have graphed here y equals 4 cosine of 3x minus 1. And you notice it's still a cosine graph. It starts at the top and kind of makes a U shape. But here there's like 3 copies of this graph between 0 and 360. And it's also stretched out and sort of pushed down a bit. We're going to find what each of those numbers does to change this equation and to change the graph. The three main properties of trig graphs that we're going to look at are amplitude, period, and vertical shift. I brought up those three terms yesterday. Vertical shift can also be called the center, but they're the same basic things. The amplitude is just the distance from the center of a graph to its maximum value. It's how far you go from the center to the top. You could also think of the amplitude as how far you go from the center to the bottom. Basically, it's from the middle to the extremes. I mentioned yesterday that sometimes people, including me, will call the amplitude height, but really it's half of the height. It's just from the center to the top or bottom. And since the normal sine and cosine graphs go as high as 1 and as low as -1, and they're centered at 0, the amplitude for standard sine and cosine graphs is 1. You go up 1, you go down 1 from the middle. We're going to graph some other sine graphs here, and if you look carefully, you'll notice what I did is I put numbers at the beginning. I have y equals 2 sine x and y equals 3 sine x. And what happens when I put those numbers there is it changes the amplitude. It's like it stretches out the graph. For 2 sine x, it goes up to 2 and down to -2, and for 5 sine x, it goes up to 5 and down to -5. So the normal graph of sine x has an amplitude of 1, but when you have 2 sine x, the amplitude's 2, and when I have 5 sine x, the amplitude ends up being 5. And you can see here the most important thing about finding amplitude. If you have an equation that says y equals a sine x or y equals a cosine x, the amplitude is always going to be the absolute value of a. Normally people think of it as just a, but if a happens to be negative, you throw away that minus, and that's why it's the absolute value of a. So here's three trig functions. See if you can think of what the amplitude of these would be. And of course, all you do is look at the beginning. So the amplitude of 9 cosine x is 9. The amplitude of 444 sine x is 444. And since it's absolute value, the amplitude of -3 cosine x will be 3. So a real common question is, what does that negative do when you have -3 cosine x? And we're going to graph that quick to see. And it turns out that what a negative does is it turns the graph upside down. Normally, cosine would start at the top and make a U shape. But because of that negative, I start down at -3. And then I go up to the top and back to the bottom, and it looks kind of like a bell when you get done. So think for a minute what y equals -13 sine x would look like. And the first thing to realize about it is that it's upside down because of the negative. Now it's not going to start at the bottom, it'll still start in the middle like every sine graph was, but it's going to go down first and then back up. And the top's going to be at 13, the bottom at -13, which means I have an amplitude of 13. If you try this on a graphing calculator, it really doesn't look too good. That's because the calculator right now is only counting up to 5 and down to -5, but the graph goes all the way up to 13. The kind of question you'll see on both tests and worksheets will show you some graphs and ask you to figure out what's the equation that's being graphed. What function is this? So I want you to look at each of these for a minute and see if you can come up with the equation, and we'll reveal the answers after a few seconds. So first we have y equals 4 cosine x, because it's a cosine graph, a U shape, and it starts up at 4. This one is a sine graph, and it has an amplitude of 3. That's how I know it's 3 sine x. Here we've got an upside down sine graph with an amplitude of 2. Because it's upside down, that's why it's negative 2 sine x. And this one is an upside down cosine graph, and it goes up to 5, down to negative 5, so I know it's negative 5 cosine x. You're probably familiar with the term AM in terms of radio. Well, what AM stands for is amplitude modulation. And that means that they're modulating or changing the amplitude, the height of the radio waves that they're sending out to broadcast the programs. Typically louder sounds or sounds with higher pitches will end up having big, tall waves, and softer sounds are going to have shorter waves. And you get a combination that looks something like what you have in this picture. Now, it's more complicated than that, but it gives you the basic idea of how amplitude modulation or AM radio works. Another term you want to be familiar with is period. And the period is just how long it takes to complete one full cycle of the graph. In physics, they'll use the term wavelength to mean the exact same thing, and wavelength is just period. So the period is just how far you have to go along the x-axis before the graph starts to repeat. And for normal sine and cosine graphs, the period's going to be 360 degrees. That's because you have to go to 360 and then it starts over. Every time you go around the circle, you have the same sine and cosine. And it turns out that the way you change the period is you put a number in front of x. Like you come up with a function like the sine of 2x. This is going to have a different period. If you graph y equals the sine of 2x, you'll notice what the calculator does is it makes 2 full copies of that graph before you get to the end 360 degrees. Since we're graphing 360 degrees and it's making 2 copies, that must mean that the period is going to be 180. You can always find the period by taking 360 divided by that number by x. 360 divided by 2 will give you 180. So now it asks us to graph the function y equals cosine of 4x. I'm going to show you what this looks like on a graphing calculator, but I'm also going to show you what you would get if you graphed it by hand, because honestly, that's almost easier. The most important thing about this function is that the period is 90. It's 360 divided by 4. So if I wanted to graph this by hand, what I would do is make some basic trig axes, put 90 at the end to show that that's the period, and then make a basic cosine graph. Start at the top and go middle, bottom, middle, top. And I've got that same U shape that pretty much every cosine graph looks like, but it goes to 90 before it starts to repeat. On a graphing calculator, you'll see what happens is that it's making 4 copies of a cosine graph between 0 and 360. And looking at that, what a lot of people will do when they're asked to make graphs is they will graph it on a calculator and copy what's there. That's fine as long as you also acknowledge what the period of this is. You could, for example, put 90 as a label right by that first dot that's showing up on the x-axis just to show that the period is 90. Again, in general, if you want to find the period of a trig function, if it says sine of something else, like the sine of bx or the cosine of bx, what you do is you take 360 over b. Technically, that's also over the absolute value of b, but honestly, that number is always positive, so you don't really have to worry about it. Again, see if you can figure out what's going to be the period of each of these functions. And all we do is take 360 divided by the number in parentheses. So 360 divided by 5 is 72, 360 divided by 8 is 45, and 360 divided by 3 is 120. Question here says, what function is graphed in this picture, and what's the period? So what you've got to do here is count how many times this repeats, and also figure out, are we looking at a sine or a cosine graph? And it's a little bit hard to tell on this, but actually we are looking at a sine graph. It would start at the origin and go up to the top and then back down and back to the middle. And if you count how many times it's repeating what it started with, there's actually 10 of these different cycles. Because there's 10 copies of the graph, that's why the equation would be y equals sine of 10x, and 360 divided by 10 gives you 36 degrees for the period. I also want you to consider what it would look like if you had the cosine of 1/2 x. Well, the period this time would be 360 over a half. And 360 divided by a half is the same as 360 times 2, which is 720 degrees. This is a graph that the calculator really doesn't show very well, because on it, since it cuts off at 360 degrees, you're really only looking at half of the graph. It's another one that's really easier just to graph by hand. I know the period's 720, so if I put 720 at the end of a basic cosine graph, that's what it's going to look like. Earlier I mentioned AM radio. You're probably more familiar with FM radio. FM stands for frequency modulation. Frequency happens to be the reciprocal of period, so it's very closely related to the period. And what happens on FM radio is instead of making the waves taller and shorter, they make them fatter and thinner depending on the variations in the sound. So the period or the frequency varies instead of the rest of it. You will often see changes in period and amplitude combined in the same problem. Like here, it's saying we have y equals 4 sine of 2x. And of course, this means that we're going to have an amplitude of 4. It's going to be stretched out as high as 4 and as low as -4. And the period should be 360 divided by 2, which is 180. If you graph this on a graphing calculator, you notice it makes 2 copies of the graph, and both of them go as high as 4 and as low as -4. If you wanted to graph this by hand, you could just make a basic sine graph, label the top 4, the bottom -4, and the end of that one cycle 180. So think what it would look like if you graphed y equals 3 cosine 4x. And again, you can see a calculator's version of that graph here with 4 complete copies. The important part on this is the period is going to be 90, the amplitude's going to be 3, and because it's a cosine, each cycle of the graph has that U shape. Now we want to graph y equals -2 cosine 2x. Negative always turns the graph upside down, which is why we get an upside down U, or sort of a bell shape. And here it's making 2 copies of that graph between 0 and 360. So the period would be 180, and it goes up to 2 down to -2. There are some graphs that you really can't graph very well on a calculator just because the numbers are too big. Here we have y equals 45 sine of 12x. What's important about that graph is that the amplitude is 45, so it goes up to 45, down to -45. The period is going to be 360 divided by 12, which happens to be 30. If I wanted to graph this by hand, what I would probably do is just make a basic sine graph, label the top and bottom 12 and -12, label the end of it 30, and call it a day. On a calculator, this honestly looks pretty ridiculous because it's trying to put too much in too little of a space. And not only is it hard to see 12 copies of a sine graph there, but they all get cut off way before they reach the top, so you can't even really see what's going on. Again, the things you want to remember for now are period and amplitude. The amplitude, how high it goes, and you look at the number at the beginning. The period is how long it takes to make one full cycle, and you take 360 divided by the number by x. We'll get into vertical shift later, but those are the main things that come into changing around trig graphs.